The three types of graphs: the position time graph, the velocity time graph, the acceleration time graph.
Hi, I am Andrea Gell. Today I will be tackling about the three types of graphs. Let's begin.
The slope of a position time graph represents the velocity. The steeper the slope is, the faster the motion is changing. Average velocity can be calculated in a position time graph as the change in position divided by the corresponding change in time. The example:
given the table of value in the left side, which is T represent time and P represent position. T has 0, 2, 3, and 4, while P has 2, 4, 6, 8. Let's plot this. 0 and 2 here. 2 and 4. 3 and 6. And 4 and 8. Let's answer the question, what is the average speed between 2 seconds to 4 seconds? Slope is equal to average speed. But how can we find the average speed? To find the average speed, the formula is slope is equal to rise over run. Given that the slope is equal to rise over run, let's find how the line rises from 2 seconds to 4 seconds. So 2, 3, 4. It rises to 8. So we have 8 meter. 8 meter because position represents meter. So how did the line run between 2 seconds to 4 seconds? 2, 3. 3 seconds. Why is it seconds? Because time represents seconds. 8 meter divided by 3 seconds is equal to 2.666 meter per second. Or 2.66 meter per second. Therefore, the average speed between 2 seconds to 4 seconds is 2.66 meter per second, and the body is moving at constant velocity in positive direction. Why positive direction? Because as we can see in the graph, the slope rises. And when we see a rises slope, it is a positive slope.
Second, velocity time graph. The slope of velocity time graph reveals information about an object's acceleration. To determine the average velocity, calculate the total area under the graph and then divide it by the corresponding time interval. The example.
So, we are now moving to the second motion graph, which is velocity time graph. Same as the first graph, we have table here, which is the table of value of velocity time graph. We have T stands for time and V stands for velocity. It has the corresponding numbers, which are 0, 0, 1, 10, 2, 20, 3, 30, 4, 40, and 5, 50. Let's begin plotting this. So, 0, 0. Here, 0. 1 and 10. Here. 2 and 20. 2 and 20. 3 and 30. Here. 4 and 40. Here. Lastly, 5 and 50. Here. So, how did the line rise from 1 seconds to 4 seconds? Here. 1, 2, 3, 4. And it rises to 40. That's why we have 40 meter per second. Meter per second is the sign here because velocity represents meter per seconds. How far did the line run from 1 seconds between 4 seconds? So here, 1, 2, 3. 3 seconds. 3 seconds because time represents seconds, as I said. So 40 meter per seconds divided by 3 seconds is equal to 13.333333 meter per second squared, or 13.33 meter per second squared. Therefore, the average acceleration between 1 second to 4 seconds is equal to 13.33 meter per second squared. Let's answer the second question. What is the displacement between 0 seconds to 2 seconds? Area is equal to displacement. The formula of displacement is area 1 plus area 2. So what is our area 1 and area 2? So here, this is our area 1, which form triangle. And this is our area 2, which form trapezoid. So to get the displacement, we will use base times height over 2 plus base 1 plus base 2 over 2 multiply height. Let's continue. So our base is 1. And our height is 10 over 2 plus our base 1 is 10 plus our base 2 is 20 over 2, and our height is 1. 1 times 10 is equal to 10 over 2 plus 10 plus 20 is equal to 30 over 2. 2 divided by 10 is equal to 5. And 2 divided by 30 is equal to 15. Bring down 1. 15 times 1 is equal to 15. Bring down 5. 5 plus 15 is equal to 20 meter. Therefore, we can conclude that our displacement between 0 seconds to 2 seconds is equal to 20 meters.
And the body is moving at constant acceleration. Number 3, acceleration time graph. The acceleration time graph is used to determine the change in velocity in the given interval of the time. The example.
So we are down to the third motion graph, which is acceleration time graph. This is our table of value. T 0, 2, 4, 6, 8. A stand for acceleration. 4, 8, 12, 14, 20. Let's plot this. 0, 4. 2, 8, 2, 8. 12. Six, 4. Lastly, 8, 20. Let's answer the question. What is the change of velocity from 2 seconds to 4 seconds? Change of velocity is equal to area. The formula of area of trapezoid is base 1 plus base 2 over 2 times height. So our base 1 here is here. From 2 seconds to 4 seconds. Base 1, base 2. Our base 1 here is 8 plus base 2, which is 12. Over 2 times 2. Cancel. 8 plus 12 is equal to 20 meter per second. Therefore, the change of velocity from 2 seconds to 4 seconds is 20 meter per second.